My name is Ivan Sharmak. I'm a solutions architect at Tegera. In this session, we'll take a look into Calico and AKS, on AKS, but also discuss several options in there for network and network policy, and take a look into some Calico Enterprise features, not all of them, but just a few commonly used features. So to start with, what Project Calico is, or commonly known as Calico, it's a community developed and managed open source solution for networking and network security for containers, VMs, and host-based workloads. Calico was designed in mind with the best performance that we could achieve. So we leverage in the native capabilities of Linux data plane to get that performance, and also setting up the layer 3 network without any encapsulation, which makes the solution to be very clean, very straightforward to debug and troubleshoot. Also, we provide the encapsulation capabilities for IP and IP and VXLAN as well. For networking setup, we use BGP to configure the routing between the nodes. So that allows us to scale to limits of Kubernetes. And the policy engine that Calico provides has been recognized by the industry and has been adopted by pretty much all the major players in the Kubernetes domain, like cloud providers and their managed offerings, AWS, Google, Azure, IBM, some packaged solutions like Docker Enterprise and Rancher, and integrated with the OpenShift. Since early days, we've been working with the customers that were transitioning or starting their Kubernetes journey, and we've tested the solution and seen how that works in production. Some of the largest customers, some of the SaaS companies, FinServ, and so forth. As of today, I believe by now we have over 200,000 clusters that we know of that run Calico, and there are many more that we probably don't know of. If you're looking to get involved in contributing to the project, or want to connect with the team, with the community, feel free to join and follow us on one of those channels. The Slack channel has close to 5,000 people by now. It's very active. If you have any questions, that's probably the best source to go and get some help. In terms of the span and footprint of Calico in Kubernetes domain, this slide kind of gives a quick overview of where you can find Calico, where it's used. On the left-hand side, you can see some of the managed offerings of Kubernetes by public cloud providers, AKS, GKE, AKS, IKS. Then you can always use it with the upstream Kubernetes. Some packaged offerings, Docker Enterprise developed by Mirantis team, OpenShift by Red Hat, Rancher, Canonical, VMware, Tanzu, D2iQ, all of that you can use either on-prem or in cloud, using cloud infrastructure. We also support Linux and Windows data planes, so you can use in a mixed cluster. You can use Calico as well, and all the way to on the right side, moving on to on-prem VMs, bare metals, on-prem data centers. It's worth mentioning that Calico can provide the security, secure your pods and containerized workloads, but also can secure your host-based services and even the VMs or bare metal machines that are not part of Kubernetes cluster necessarily. Let's take a look into AKS networking options. When you're setting up your AKS cluster, what you have available in there. There are a few options for network plugin, the KubeNet and Azure CLI, and a few options for network policy, either Calico or Azure. So the The default option when you build the cluster and just specifying the network plugin kubenet, that gives you a host local IPAM without any policy installed in the cluster. If you want to create the, if you want to have your cluster to support policy, then you would use kubenet with network policy Calico, or if you want Azure network policy, you can use network plugin Azure and network policy Azure, and also you can use the Calico for that option as well. It's worth mentioning that once you build the cluster, you cannot really turn on and or off policy on demand or add the policy capabilities on demand. So that's a decision that you need to make before you build your AKS cluster. Quick look into how things are getting set up on the Azure side once you're setting up the your AKS cluster. Your nodes would be connected leveraging the Azure networking. Each pod on the node gets a VEF pair. One end is hooked into the pod that ends up to be ETH0 in the pod, and on the node side, that's going to show up as a VEF interface that will be then connected to a bridge, and the bridge will further use the Linux kernel routing and direct the traffic from there. The Azure provisioner sets up all the necessary configuration to carry the traffic to allow the pod-to-pod communications between the nodes. So all the user-defined routes, the IP forwarding, all of that is configured for you, so you don't have to worry about that. Any traffic with a basic networking option or kubenet option that is leaving the node is going to be netted, because the cluster IP range is different from the subnet where nodes reside on. So that's any traffic that is leaving the node will have to be netted. So let's take a look how this would look like if you use kubenet plus Calico option, where Calico CNI would be used and host local IPAM is used. So it's similar setup. The few differences are that your VEF pair interface gets Kali prefix on the node side, and the bridge, there is no necessity to use bridge. Calico simplifies that setup by just programming the Linux kernel and leveraging the soft switch, and therefore removing the necessity to have the bridge, simplifying the networking setup and getting some performance boost out of that. The rest is very similar. Any traffic leaving the node is going to be netted. So here's an example how the pod-to-pod communication would happen. Moving on to the advanced networking option where Azure CNI is used. In such setup, you'll get your interfaces to be prefixed with AZV. When you're using the either Calico or Azure for the network policy, you get the ability to program the firewall rules for your pods. With Calico, you'll get also that can be extended to protecting the host-based services, host ports. Each IP, when using Azure CNI, each IP that is allocated for the pod is drawn from the same subnet your VMs reside on. So they are just added as secondary IPs to your Azure network interfaces on the nodes. And now the communication between the pods and between the pods that live on different nodes is not netted, because you can directly talk to those IPs to the pods using their IPs. So that gives you some advantage when you want to connect other services, Azure services, and want to allow them to talk to the pods directly. The third option I'm going to mention is when you can use pure Calico, where Calico CNI is used with Calico IPAM. That's going to be a self-managed cluster setup where you would have the control over installing which CNI you want to install in your cluster. Where that's typically used when you need some advanced capabilities of Calico that Calico CNI can provide, like additional IP pools. If you want to map out those IP pools to different nodes, different types of applications. If you want to peer, for instance, on-prem, you want to peer with your existing infrastructure with top-of-the-rack switches, or if you want to advertise the cluster IPs or service IPs outside of your Kubernetes cluster to the rest of your infrastructure. If you want to provide stable IPs for your Kubernetes pods, all of that are features of Calico CNI when using Calico IPAM. So in those cases, when you need those advanced capabilities, that's where Calico CNI and Calico IPAM can help. Also, when using Calico CNI and Calico IPAM, you'll get an ability to create a network with encapsulation. On Azure, VXLAN is one option that is supported. If you're using that on-prem or in other cloud providers, you get two options, IP and IP or VXLAN for encapsulated traffic. To sum it up, let's briefly go through a few bullet points on what options you get and what networking considerations you need to think about. So you get options between non-routable network with, in case of Kubernetes setup, or routable network where Azure CLI is used. With non-routable network, you get host local IPAM, and you get /24 IP range for pods on each node, or that's /24 per node. If you're using Azure CLI, then you need to do some homework and calculate the size of the subnet that you're going to use. And you need to factor in some future anticipated growth of the cluster, how much you want to scale that, as well as add some or factor in some scaling and upgrade requirements for the cluster. Here's the formula for calculating the minimum required cluster size, and in this formula, when you're using number of nodes, that number should include what you anticipate to scale in future. Changing the size of the subnet for the cluster IP range for AKS cluster is not trivial. So typically that ends up when you need to expand that, you end up rebuilding the cluster with a new range. Another thing to mention here, that by default each node allows to create 30 pods per node. You can adjust that setting to maximum value of 250 pods per node when using Azure CLI. On the Calico networking options considerations, worth mentioning, reiterating, then when you're using Kubernetes and Calico for network policy, you get Calico CNI with host local IPAM. When you in that option, that would be an AKS managed version of Calico. So that means that whatever version of Calico AKS installed, you cannot change that, you cannot upgrade that, you cannot change that. If you do that, AKS provisioner or operator will come back and just reconciliate that to whatever version it installed in there. If you want to install any version you want, then you would opt for unmanaged installation of Calico, and by unmanaged I mean AKS would not be controlling that piece. If you want to use Calico Enterprise on AKS, you'll have to use Azure CLI, and you have to set the transparent network mode for your Kubernetes cluster. For pure Calico option, I mentioned the usage of IP pools, so you get some additional capabilities and additional controls in terms of how to configure your networking. and how to fine tune that. So the IP pools is one of the resources that you can leverage in there, and you can decide what size of IP pool you would create. By default, you get the if you don't specify that, you'll get the entire size of the subnet you allocated for the pods. But if you do, you can create multiple different IP pools, and then you can control how to allocate them or whether you want to assign them to a specific type of nodes, like a node with a specific label. Just to reiterate, in terms of network policy, what you get that you get the AKS managed version. You get the for any other version that you want to use, you would set up. You would create a Calico. You would create AKS cluster with Azure CLI transparent network, and then just install Calico on top of that. So without specifying the network policy option as you build the cluster. So in that case, you can install any version you want. There is a comparison table between the Calico open source features and Calico Enterprise. It's too big to fit into the slide, so I added the link, and these slides will be available after this session, so you'll get the access to there. Let's take a look into a few features of Calico Enterprise, or the added value that Calico Enterprise provides. So when you using Calico Enterprise, you get additional controls that you can leverage to fine-tune your access to cloud services, to third-party APIs, to any other hosts, and potentially any databases or any other services running either on-prem or in cloud, and you can control that access on per pod basis. So Calico Enterprise has, for instance, DNS policies where you can configure rules, egress, access rules based on a specific DNS or a mask of that DNS. The wildcards are also supported in that in the policy configuration. Also, one of the tools that customers use heavily when they use Calico Enterprise, that's Flow Visualizer, which allows you to see the flows in the cluster between any workloads within your cluster and traffic moving outside of it, which has some additional controls to kind of filter out down to any specific namespace or any specific workload or even any specific flow. So that allows you to see what's happening in the cluster real time and what if there are any issues like the traffic is blocked by the policy, it's very easy to visually see what's happening and kind of quickly solve the problem. Also, Calico Enterprise provides some additional features around the policy lifecycle. You can do the policy preview, policy staging, which allows you to kind of create this policy lifecycle loop where you can create policy, stage that policy for, and observe it for some time before you get confident that it's not going to harm any of the existing workloads. Enforce that policy and just go through the rest of it, update, delete, and repeat the cycle. With the feature of policy recommendation that Calico Enterprise has to offer, you can enable your developers to create policies for the applications without having them to go and kind of learn all that convoluted YAML and start kind of writing everything from scratch. So the policy recommendation allows you to quickly get a policy template from the existing, using the existing flows observed in the cluster. And you can then just either review that and decide that it's all fine, just go ahead and stage that, or modify that, refine that further. So that allows you all the access to different policy types in Calico. It's all Kubernetes resources, so therefore Kubernetes RBAC can be easily applied to that, which means now you can create. You can give your development teams, for instance, the ability to stage the policies, create and stage the stage type policies, and not without allowing them to actually deploy and enforce those policies, so that they don't break any existing workloads and have another team that will be responsible for enforcing those policies. Another feature of Calico Enterprise is the layered approach to policies, or the policy tiers, where you can create multiple tiers and stack the policies in those tiers. And it's all as well RBAC supported, Kubernetes RBAC supported. So now you have an ability to give the access to different teams to manage only policies within specific tiers, or only specific type of policies within the tier. So in this example, the InfoSec team can refine any traffic and create the policies to refine the traffic, which would be allowed to go further and hit the platform team and app team. And in turn, the platform team has the ability to refine the traffic further for the application team. And typically, you would map out these tiers to the organizational structure and kind of give them access based on that. Let's take a quick look into comparing Calico to Azure Network Policies. So out of the box, Azure gives you CNI plugin and full support for Kubernetes Network Policy API for egress and ingress. On top of that, Calico adds the capability of running on multiple data planes, Linux and Windows. Azure policies only supported on Linux today. Calico also adds some additional controls and additional features for the policies, like you can negate matches, you can create quite complex combination using Boolean operators for your selectors. You can use different protocols, you can protect the hosts, you can use global policies and network sets. All of that is bundled up and included into Calico open source. And with integrating with Istio Envoy, you get access to creating layer 7 policies. On top of that, Calico Enterprise adds the hierarchical network policy management, or the policy tiers that we just talked about, DNS-based network policies, multi-cloud support, and federation. So for the multi-cloud, you get this single pane of glass to connect all of your clusters together in that single pane of glass, and you can from there manage any policies. You can view the traffic moving through the clusters and kind of jump into troubleshooting if there is something, or if there are any anomalies detected in the cluster. There is RBAC controls, audit trails, and continuous compliance reports that are part of Calico Enterprise. Monitoring and alerting capabilities, the single sign-on for Enterprise Manager UI, and the threat defense capabilities. And it's only some of the features of Calico Enterprise. The full list, you can go to the website and take a look at all the capabilities that are there. So for the Calico Enterprise, we offer hosted trials where you can get a cluster built for you, and we provide some commonly requested use cases. We provide a guided labs for those. If you don't know anything about it and you want to try it out, you can head to tegera.io/trial and get the requester an environment to be provisioned for you. If you feel comfortable with it, you've played with it before, you used it before, and you want to test a specific use case, you can also use that environment just to test out any use cases that you want. Now I'm going to jump into a small demo. And for the demo, I have built a repository on GitHub under Tegera Solutions. Install Calico on AKS, which gives you some instructions how to build an AKS cluster using two approaches in here. So I already built the Calico Enterprise cluster because it takes a little bit a little bit more time to set it up. So in this session, I'm going to kick off the creation of the cluster with Calico open source and proceed through some of the demo use cases. So let me jump here. And set up the region, a few variables. So before I do that, let's take a look at what versions of Kubernetes are available, because it gets updated every week. So in my location, I have 1.18.8, so there is a newer version. Let's use that. And now create the group and set up the service principal and configure that service principal for the group. So while it's doing that, I'm going to copy the next command, which will provision a cluster with 2 worker nodes. And there are some parameters in here that I'm setting up. So in this case, you can see I'm using the network plugin KubeNet right here and the Calico for network policy. So that's going to be the setup that I was mentioning, that AKS managed version of Calico. Typically it takes several minutes to complete this. So while we waiting on that, I'm going to show you what I've got in the in my other AKS cluster, which has Calico Enterprise set up. So I have also version 1.18.8 in here, 2 worker nodes. If you take a look into the pods deployed in the cluster, you'll see there is there are a bunch of Tigera hyphen namespaces in here. Those are all attributes of Calico Enterprise and holding the enterprise components, running enterprise components. And if I take a look into the version, of this Calico, so you would see that the version I'm running is 3.16.1. And the CNX version, that's a version of the enterprise Calico Enterprise components. That's version 3.3. That's our latest release at the moment. So while I'm waiting for that cluster to be provisioned, let me see if there are any questions that I can answer. Okay, there are a few questions. So the network, first question, network plugin Azure, network policy Calico. I'd like to see pods IP addresses at the external firewall. However, they're hidden behind the node's IP. Calico CDL patch IP pool default IP pool with not outgoing false. Changes this behavior for a while, but after 5 minutes, this parameter becomes true again. How can I turn NAT completely? So when you're using Azure as a network plugin, you cannot really control that, because the Azure CLI would be controlling all the netting, and Calico has no say in it. If you start adjusting something there, that's kind of what I was mentioning about Calico version as well. If you try to upgrade a Calico version or just replace it with a newer version, after a couple of minutes, AKS operator will come and reconcile that to the version that it installed originally. The same goes for any configuration, any settings that you will try to adjust for the CNI. You cannot do that when you're using Azure CLI. That's all controlled by the cloud native implementation of container network interface. And there is a question about the demo, and yes, we are in the demo right now. So If there are any other questions, you feel free to post. Otherwise, I'm going to move on to the demo scenarios that I prepared for this. So let me take a look. Okay, while that cluster is building, let me deploy an application that I've built for the demo. So just to quickly show you what that application is, what it represents, I have created a namespace, demo namespace, deploy Nginx stack into that namespace, and 2 utility pods, one using CentOS, the other one using Netshoot image. So let's go ahead and deploy this onto our Calico Enterprise cluster. And double check that we got everything running. Okay, the Netshoot container is getting created right now. And so what these pods are doing, and let me switch in here where I already got the prepared the commands to run. So on the top right corner, you can see the window that represents the CentOS pod that continuously curls Google. You can see somewhere here, Google column shows up. And at the bottom right window, you can see the Netshoot pod that continuously curls the Nginx service or Nginx application deployed into the same namespace. So what I'm going to do in here is I'm going to implement a default deny policy. So by default, any policies in your Kubernetes clusters, by default, there are no policies, which means any traffic, pod-to-pod communications are allowed. Any pod can talk to any other pod. Once you have any policy deployed that affects those pods, any flows for the direction of the policy flow that you define, anything that is not explicitly allowed will be denied. So it's kind of acts like a switch from allow everything to deny, default deny, except for whatever is allowed in the policy. When following the zero trust networking approach, you can, and typically how it's done, you would implement an explicit default deny policy and start whitelisting the traffic that you need. So in my case, what I'm going to do in here, I'm going to deploy this default deny policy. And actually, before I do that, let me do that on the cluster that was just built, so that I can show you first how what you would get in the using Calico open source, and then what the scenario for Calico Enterprise. So for this cluster, I can show you network profile, and that's where you can curl the your AKS cluster metadata and take a look how it's set up for the network plugin in the policy in here. So in enterprise cluster, if I run the same command, you would actually see that there is no policy in there because I did not explicitly tell it to set up any policy. So you could see that my network plugin is Azure, but network policy is null, which means now I can install any version of Calico for network policy as I want and not have AKS to manage that. So let me proceed with this scenario just on my newly built cluster. Oh, I need to grab my kubeconfig. That's what I didn't do. Okay, so I got my cluster built, and let's take a look at cluster informations. And the Calico versions installed in this cluster. So you can see that Calico version in this one is 3.8.0, comparing that to what we had in Calico Enterprise, which is 3.16.1. So if you do need to use newer features of Calico, then you better to opt for an option where you would install that version and not let AKS to manage that. Okay, getting back to my demo scenario where I can deploy my app. Okay, it's getting deployed now. Let's watch this. And I would get 2 of my pods. So let me do this. I'll change this a little bit. And change the okay, so this is my cluster with Calico open source. I got my application running. And let's start reading the logs from each of the utility pods just to make sure that I'm getting the responses in there. Okay, looks like I actually grabbing the output from the 2 of the same. Yes, I do. Okay, so the top right, that's curling Google, and top and bottom right, that's curling the Nginx pods. So let's implement our default deny policy, which is just standard Kubernetes default deny policy. And let me deploy that, and I'll can show you in a moment. So if I jump to default deny policy, what you can see in here, that's a standard Kubernetes network policy where I'm defining, I'm saying that I'm applying this policy to all of the pods within the namespace demo. And I'm specifying that this is ingress and egress policy, but I'm not setting any rules, which means anything that is not configured will be denied. And to be honest, I did not switch the context on this pod, and that's why these pods just keep working, because they were pointing to my Calico Enterprise cluster. Okay. Okay, so I needed to adjust a few things in here. Okay, so now you can see both of my pods, they cannot communicate with whatever the service they were curling in both of these cases. And if I jump quickly to show you how this would look in Calico Enterprise. The landing page of Calico Enterprise gives kind of like this view of all the connections, allowed bytes, denied bytes, any of the evaluation of policies live over live traffic. And if I jump to the policy, you would get the view of all the policies in the cluster. And I just realized that my Calico, I'm working on the demo for Calico open source cluster, so I don't have any UI for this one. So the only tools to me available that's basically trying to look into what policies I have deployed, like get network policy across all namespaces. So in my case, I have these two policies with tunnel front that's deployed by default by Azure. And I have this default deny over my network, over my demo namespace. So the next step for me would be, let's start whitelisting the access for my pods. So the first, I'm going to allow egress from the CentOS pod. And you can see right away it gained the access to Google domain. And if I take a look into the CentOS egress policy, you would see that it's a namespace policy that applies to the CentOS pod, and all it does, it allows UDP traffic over port 53 so that I can do DNS lookups. This pod is allowed to do that, and I'm just allowing any other TCP traffic. That's what allowed that pod to get out and start communicating. So for the next one, what I'm going to do is deploy ingress and egress policies for Nginx and for Netshoot. That's two of my other policies. Here's the policy for Nginx, where I'm allowing ingress over port 80. And for Netshoot, I'm allowing egress over port 80. So let's deploy this too. So we deployed these policies, which allow this specific flow, but our Nginx is still not able to communicate with the Netshoot is not able to communicate with the Nginx. And the reason for that is that once you deploy default deny, or once you deploy any egress policy and do not explicitly specify the flow or allow that in some other ways to, like in Calico Enterprise, we'll take a look in the example in a moment, and allow that adds to the egress rule the connection to DNS server, then you are not able to communicate with the pod using the service name. I can communicate with the pod using the IP, but not the service name. So for that, I'll have to deploy this policy that allows DNS access for all of the pods within my demo namespace. It allows the communication over using UDP protocol over port 53. So once I deploy that, now you can see that Netshoot pod got access to the Nginx. Okay, let's do the scenario now in Calico Enterprise and take a look how this would be working, and refine this example a little bit. So for my Calico Enterprise, let me switch actually the I need to set the context. So let me set the correct kubeconfig and get the nodes. Okay, this is my agent pool. This is Calico Enterprise cluster informations. Yes, this is my Calico Enterprise. And just to take a look at the network policies in this cluster. So I have nothing in here in terms of network policies. So let's go ahead and deploy our application. And let's take a look, actually. We have our demo namespace. Okay, it's in there. And I already have the app deployed in here. Okay, so what I can do now is to run my commands to tail the logs of both of those pods. So you can see both of them can communicate with the services. So what I'm going to do now is deploy a security tier to which I will start adding some of the some of the policies. And to show you the policy board in Calico Enterprise, so you have your default tier where typically application policies go into, and then you can have other tiers like allow Tigera is installed by default when you install in Calico Enterprise to allow all the communications between Calico Enterprise components. So I'm going to hide that for now and create a new tier called security. And now deploy the default deny policy, but in this case, and let's take a look briefly into this. In this case, this default deny is not going to be a Kubernetes policy, but rather a Calico policy. And there are some differences in the a few differences in Calico policies where you get the access to order field, and you can basically sort your policies using that field. When you're configuring default deny policy, you should make sure that that policy is the last policy in your policy board. It's kind of acts as a catch-all policy for any traffic that is not explicitly allowed by any other policies. So let's deploy this policy. Okay, so default deny is in place, and now both of my pods should stop communicating with whatever services they were currently. So you can see Nginx cannot do that, and the CentOS pod as well. So for the next step, let's start looking into. I can deploy a few things in here, but before I do that, I can deploy additional, I want to show the DNS egress policy. But before I do that, let me show you what you would see in Calico board. So right away, you start seeing some traffic getting red bars showing up in this histogram packets by policy, showing you that there are denied bytes. And if you start looking in here, you could see that there is some traffic getting denied. So that gives you a clue that there is something that's happening in the cluster that policies are getting denied, or the specific flows getting denied. And if you hover over it, you can see the policy name right in there, and clicking to it will transfer you to the policy, where you can kind of see right here. We can see that there are some denied packets going through. So if I jump to the policy tiers or policy board, you would see my policy deployed in here. That's my Calico default deny, which is the last policy in the default tier. So next, let's deploy DNS egress policy, which should grant the access for a CentOS pod. Okay, so the CentOS pod is able now to get out. And let's take a brief look into that policy. So in this policy, I'm using it as a global network policy. meaning that it does not necessarily apply to any specific namespace, but rather to all of the workloads. And with this selector, you can refine to which specific workloads or even namespaces. And here there are Calico managed labels that represent, that can target namespaces that you can use in this selector, and then allow the policy to target specific group of namespaces. So in this policy, I'm allowing access to kubedns, and I'm allowing access to domain external, and blocking all the access to this type public. And what these references are, these labels, they're referring to network sets. So I have a global network sets where I defined the allows egress domain for Google, and allowing that's how CentOS is allowed to get to Google. And for IP sets, I just defined a bunch of public networks, ranges for public networks. And that's how this policy in here, I'm saying that I'm not allowing any access to any of those networks except for egress to the domains defined in this network set. And just to confirm that, let's try to use CentOS to curl something else than Google. So if I do it from here and curl Google, I should confirm that I can access it. But if I go ahead and try to curl something like Bing, now I'm not able to. The request just hangs. If I put a timeout in there, it should be a little bit faster to fail. Yep. Okay, so once I confirm this, let's allow the Nginx to get access. And how we can figure this out, if we go into Calico Enterprise and jump to the flow visualizations to look into the flows in the cluster. Let me expand this to last 15 minutes. Looks like my session has timed out. Let me relog in. Okay. So if I'll shorten this span to maybe like last 5 minutes or so that we don't look into all the traffic prior, drill down into my namespace and start looking into what's happening in here. So if I switch to just see the traffic flows in binary format, allowed, denied, I can see right away that there are some denied flows. So if I start hovering in here over this flow, so I can see, okay, this is my DNS netset egress policy that is blocking some access from CentOS to going outside to the public. And here you can see that it's blocked by that public IP range, which is my network set. And if I hover over this, the net shoot, I would see, okay, my net shoot flow is blocked by this policy. So let's go ahead and modify this policy. So in this policy, I have defined that I'm allowing access over port 53, UDP access, allowing egress to external domain, denying everything access to the public IP addresses. And that's because I'm not explicitly specifying that netshoot can communicate with the Nginx is allowed to. So that's why it's the communication is not happening. What I'm going to do is to say for anything else, just to pass this traffic to the next tier. And that's an example of how you can use the pass action with Calico Enterprise policies to let next tier decide and policies in the next tier decide what should happen. So I'm going to enforce this and jump to my board. Okay, I do not see anything blocking. So now I allowed that access, but you can see my netshoot is still not able to curl the Nginx. So and for that, what we need to also do is to deploy, since I have the default deny policy in place, I need to explicitly allow my Nginx to curl the flow from netshoot to Nginx to happen. So I'm going to deploy this to egress and ingress policy, and so now you can see that Nginx is able to access it. Okay, that's an example how you can use both Calico Open Source and Calico Enterprise, and how Calico Enterprise, some of the tools, especially this flow visualizer, allows you to kind of see what's happening within the cluster. And if something is getting blocked, how quickly you can identify what is happening, why it's getting blocked. So you can still see some of the flows for the last minute were blocked. But now you can see that shows up a new egress policy, which says it is not blocked. So after like next 30 seconds or within a minute, the old flows will move out of this time frame that I selected, this filter, and all the traffic will be moving through. So if I select the new traffic coming through, you would see all my policies in here showing that for this flow, which policies, which ingress or egress policies are participating and getting evaluated during this flow. Okay, that concludes basically my demo. Let me show you a few resources in here. So for any resources about Calico Open Source, go to projectcalico.org. For Calico Enterprise, go to tigera.io. And the solution, all the examples and for the demos and the steps to set up AKS clusters with Calico are in this repo, Tigera Solutions install Calico on AKS. And I'll check on any questions. Okay, so there is a question. Is there a GitHub repository for the demo? Yes, that's what I just showed. So let's take a look. You can find it in this repo, and that's the repository from which I was copying all these commands. So if you get to Tigera-solutions, you'll see there is a bunch of other repositories in there with different examples and different use cases. Okay. Any other questions? See any comments? Okay, I'll keep the session open for another minute in case someone's typing a new question. Otherwise, thanks for attending this session. And you can always go to tigera.io/events and check any upcoming sessions that we have for this free online training. And again, if you want to try out Calico Enterprise, you can use a hosted trial that we offer. Just go to tigera.io/trial and request an environment to be provisioned for you. I didn't see any new questions, so I'm going to wrap it up. Thanks for attending the session, and have a good day.